So hello guys, here we have question number 29 from Build Up Your Understanding exercise of the chapter Oscillation and Waves from Pathfinder. So let's look at the question first. Walls, floor and the ceiling of a large hall are covered with a perfect sound absorbing coating. A powerful point source that can emit sound waves at a frequency of 2 kHz isotropically in all directions is installed at a height of 5 cm above the floor. Speed of the sound waves in the air is 340 meters per second. A small but very sensitive microphone is installed at a horizontal distance 4 meters from the source and height 3 meters above the floor. The microphone is connected to a very sensitive voltmeter, reading of which is proportional to the amplitude of sound waves received by the microphone when the sound source is switched off. The voltmeter reads 0.1 volts. So, in the part A, we have been asked if the sound absorbing coating on the floor is completely removed, how much will the voltmeter read? And in the second part, now the floor is again covered with the inferior quality of the sound absorbing material that absorbs only 50% of the incident sound energy. How much will the voltmeter read? So, if you want to give it a try yourself, you can do it now. So, if you want a hint, here it is. Consider interference. It's an easy problem, so I've given us very small hint. So now let's look at the solution. So first of all, let's consider the diagram of the thing what is happening over here. We have assumed A to be the source. This surface is the floor, and this point is the where we have kept the microphone. Here, capital H is 3 meters, L equals to 4 meters, small h is equals to 5 centimeters. So we can clearly see that this distance is very small in comparison to these two distances. And in the case when the floor was totally covered with the sound absorbing substance, the waves reaching the detector will go along this path only. And when in the part A, when the floor has been removed of that material, it will also be going along this path and reflecting and again going along that path. So here will have to consider interference in the case when there is no coating on the floor. So now, so what we can say from here is that when the room was totally absorbing, all the sound reaching the detector was solely from the linear transmission of the sound. But in the cases given in the question, when we remove the covering of the floor, we shall also consider reflection of sound from the floor. Exactly what I said. So, and we have to consider interference of the sound. So now let's look at the calculations involved. So from here, so first of all, let's try to find the path difference of the two waves reaching the detector, which shall give us the phase difference of the two waves. So the path lengths of the two paths are, one is this path length and one is this path length. The lower path length can be said to be this path length. So from here, what we can get is the path length of the two can be written as by Pythagoras theorem. This length can be given as this length whole squared plus this length whole squared under root of the whole. So L squared plus h whole squared minus and this path length will be this length and this length. So it will be L squared plus h minus h whole squared. So from here, what we can get is here opening this bracket, what we can get is h square plus small h square plus 2hh. But here what we can see that h is very less than capital H, so the second order term, which is h square, can be neglected, and so we get this. Now taking root of L square plus h square common from both the brackets, what we get is root of 1 plus 2hh over L square plus h square, and 1 minus 2hh over L square plus h square. And so again this term has the term small h, which will reduce this term to quite a extent with respect to 1. So by applying binomial expansion here, we can get that here 1 plus half of this term, and that gives us 1 plus hh over L square plus h square, and similarly doing for this one. And so the 1 cancels, and so the path length we get is approximately 2hh over root of L square plus h square. So the phase difference from here we can say for any wave will be 2 pi by lambda times the path difference, and here the path difference is this. So substituting that, we get the value of phase difference to be 4 pi hh over lambda times root of L square plus h square. So writing the formula for interference, what we can get is the amplitude at the detector due to interference of two amplitudes A1 and A2, which having a phase difference of phi delta phi, we can get this will be its amplitude. So substituting the value of A1 to be A and A2 to be A, and cos of delta phi from above, we get this value. And we know that R is the reading of the voltmeter is directly proportional to A. So from here, what we can get is we can substitute AD to be RD, the reading of the voltmeter in the case of when the absorbing substance is removed, will be equals to R naught times root of this thing here. And substituting the values of capital H, small h, capital L, and capital H, and lambda can be found from the velocity of the sound and frequency. So substituting all of these in, we get the value of reading to be 0.0891 volts. So this is for part A. And similarly, in the second part, when the surface is 50% absorbing, the only difference will be that the reflected wave will have less amplitude, which can be found out by using the property of the wave, by which its energy is proportional to the square of amplitude. So as the energy is proportional to the square of amplitude, after the reflection, the amplitude of the wave becomes A naught by root 2. So substituting this and all of the other calculations will be the same. The phase difference will be exactly the same. So from here, the amplitude at the detector, again using the same formula, what we can get is, and on substituting this value in place of A2 and A2 in place of A1, we get the value of the amplitude at the detector to be this value. And on doing the appropriate calculations, we can get the final answer reading of the voltmeter to be 0.0805 volts. Here I have made a typo. This should be 0.0805 volts. So yeah, that is the final answer. And yeah, one more thing, I have started a Discord server, guys, and that is mostly due to the many of your doubts won't be able to be cleared through these videos, because I'm not able to make videos at that fast speed. Like, I can post only one video per day. So you can ask your doubts in that Discord server too, and you can find some other content also. So do join the Discord through the link in the description. So yeah, that's all for today, guys. Thank you. Hope you liked the video.